Hi everyone, I am LeRenzo, and today we're going to be talking about Unity and HTML5. So we're going to talk through a few things. First of all, why would I choose Unity? What does it do? And how are we actually making this work with something called Chromium Embedded Framework? We'll talk about how to actually do that. And then also, what are some of the problems that I wish I knew before I started with this, things to make it easier for you. First off, LeRenzo, why wouldn't I just use A-frame? I mean, look at this. I can write HTML, and I get 3D objects. All I have to do is pull something from a registry, pull it right into my project. I can pull it into the inspector. I move things around, and it changes the code for me. Why would I use a video game engine when I already have all of this functionality? And look at these UIs. HTML gives me everything that I need. I can use Angular, I can use React, I can use Vue. I mean, video game UIs are much simpler. Even the best ones look like this. And when you add more things, they can look like that. I mean, I don't think this is something I can go to a client and say, this is acceptable. So how am I going to get this beautiful functionality inside of a video game engine? And who even does this, right? Like, back in the early 2013, The Sims was one of the first games to ever use a technique like this, where they actually took HTML UIs and they put them as their main UIs in the game. And what this did for them was it allowed them to get web developers to actually make these things. And it also allowed them to update their UIs in real time without having to send a whole new update of the game. This really leveled the playing field and changed a lot of things for video games. And if we went forward a little bit, Massive Incorporated actually used this technique as well to put in-game ads that would change every day. Right? So you could actually view something on YouTube inside of a game, and this was also very new. Nowadays, people are starting to use Unity and video game frameworks specifically for things like architecture, where I want to look at how I'm going to present, how something, when it's done, is actually going to be in the real world, and I can use AR and VR to look at it. And I can also put this in the browser for clients to send it to them so that they can use their own phone to look at this. NASA is starting to use VR and AR as well with a project called OnSite, where they're going to allow scientists to actually work virtually on Mars. And there are partnerships with Microsoft HoloLens and medical centers to be able to visualize while learning what you're actually doing with a patient and what the inside of their body actually looks like. And they can get more information as they're actually working on, say, a dummy patient. So there's a lot of really good use cases for using a video game engine, especially if we want more information nowadays. But the hard part is actually figuring out how to make it work. So we're going to be using something called Chromium Embedded Framework. And what Chromium Embedded Framework is actually an open source library or framework that allows us to embed more or less Chrome inside of a desktop application and have the desktop application message with it. Right? This is how we use something like Electron. How many of you guys have ever used Electron? Right? So Electron actually works with exactly the same thing. Right? It uses Chromium Embedded Framework to produce a UI, and then we can just use an HTML5 application and run it as a desktop application. So that's things like GitHub, Atom, Slack, Skype, Beaker browser. You guys saw that this morning, and a whole lot of other things. Right? So a lot of people are starting to use this because it makes it much easier for web developers to actually create desktop applications. So why not just Electron? Like, what does Unity actually give me that I can't already just use A-frame and Electron for? So there's a few things that Unity gives us that we definitely can't get in Electron. One of the things that exports to literally everything on the planet. Every single device, every single headset, every single console, every single phone, everything that we can possibly use it will export to. And also, obviously, because of VR and AR support, if you're making a VR AR application, not just in the browser, but also in the desktop, because again, it works with basically everything. Also Arduino support. And for me, the biggest thing is the asset store. It's absolutely stunning. All of the things that I can pull in directly into my project without having to do any work. And I'm all about reducing the amount of work that I have to do. So these are all the devices that it will export to. As you can see, this is basically every hardware device that people play games on or use for browsing the internet. on the planet, all desktops, all consoles, Xbox, PS4, Wii, all phones. And Unity is actually used to produce over 75% of all the world's VR and AR applications. That's a lot of things. The vast majority of things are actually produced on Unity. So that means there's a lot more things that you can pull into the store. The asset store is awesome. This is one of my favorite aspects of Unity, where we can actually pull in 3D models, we can pull in animations, we can pull in 3D environments, we can pull in scripts for AI, we can pull in scripts for working with your editor. The editor is also extensible. And if we just look at the numbers, the asset store, compared to, say, all the things I can pull in from NPM for A-Frame, there's about 358 of them. I pulled this a few days ago, so maybe there could be something new, but that's pretty recent. Unreal has about 5,700, and Unity has about 58,000. Right? So the number of things that I don't have to make is significantly larger in Unity versus everything else. The editor, as I was saying, is absolutely fantastic. Just like in A-Frame, I can pick and pull things with my GUI, with my desktop GUI. I also have a whole lot of extensions that allow me to change any of the terrain, any of the properties of the objects. It's extensible, so people will make tools for giving you grids and working with more things inside of the editor, making it easier to make lines, making it easier to make different types of characters or scripts. So the editor itself is actually quite amazing. And Unity also gives us a lot of shader support. So what are shaders? Basically, when we make a 3D object and we want to give it a color, or we want to make it metallic, or we want to make it reflective or rubbery, something like that. These are all done with shaders because the GPU effectively allows us to do that significantly faster than we could in the CPU. And the GPU will basically just do all of the math for you as long as you provide it with the function. That's what a shader does. And we also have the ability inside of Unity natively to just use a shader graph, which will allow us to take effects from one to the other to make really complex effects and animations. And this is just for basic shaders, right? Unity also works with more complex shaders that we can use in mobile and desktop applications. So geometry shaders allow us to take a normal geometry and extrude it to something more complicated. If you had, say, a cube, you could extrude it to something much larger than that. You can obviously do that even bigger. But we can also use compute shaders, which I think are one of the coolest features I've ever seen. And compute shaders basically allow us to actually just do math on the GPU, right? So if you want to run an AI algorithm, if you want to use it to simulate flocking of birds or fish, all of this code, all of these updated positions every frame never run on the CPU. This is one of those effects which makes your game or your application run significantly faster. So also if you're using AI, say, in TensorFlow, right? TensorFlow uses OpenCL and CUDA in order to do this directly on the GPU. This is exactly the same logic, right? So you can run a lot of those algorithms in a compute shader inside of Unity itself. And this is one of my favorite features, which is the Cinemachine timeline. You know, I started years ago doing animation, and these timelines are the way that you can use something like in After Effects or Maya to create an animation of a 3D object or a 2D object or anything else in your scene and make it easily animate from point A to point B over time and see what's happening. And now Unity actually has this directly built in to the editor itself. And what's really cool about that is people are now using that to start to make movies and film inside of Unity, right? And again, one of the best things you get with this is also VR support and AR support for free. So if you want to make a VR movie, if you want to make any other kind of film, you can do that directly from within Unity itself. And you can pull in all of your assets from the asset store. So everything becomes significantly easier, and you have to do less and less work yourself. But the question is, how do we bridge the gap? How am I actually going to use HTML5 for what it's great for, namely the UIs, while using Unity for what it's good for, namely the visualization layer? At the end of the talk, we want to be able to make something like this, where we have a 3D object in the background, and in the foreground we have our 2D layer, which is our UI. And those are going to work together. Layer in the front I can use in HTML. Layer in the back is going to be Unity, and I can use them entirely separately for what they're good at. So that's basically a 3-step process. Not too bad. First, we have to set up Unity and the browser. And then we'll have to figure out how to send messages from the browser to Unity and how to send messages from Unity back to the browser. So as I said, we're effectively going to be having two separate applications laid on top of each other. One is the HTML application layer, which we can build and test entirely separately. And the other is the Unity application layer, which we can build and test separately. And I'm going to be using an asset called the embedded browser asset. This is actually available on the Unity store. And what it does is it wraps Chromium Embedded Framework inside of a Unity object, and we can communicate with that asynchronously, register callbacks for functions that will happen on the browser, as well as communicate with the browser easily. And in the WebGL version, we're going to take that out and just use the browser itself. So this does effectively something like this, where inside of a game, you might have an object that's a plane, and on that plane, we can just point it to a URL, and that's effectively what's going to show up at that space. Now, for today's goal, what we're actually doing is overlaying that directly on top of the Unity space, but you could also put that into an in-game object. So again, if you're making a VR or an AR application, you can actually have that show up inside of the application and interact with it, just like you know with a normal UI. You can register click functions, click events, hover events, mouse down, key down events, all the same, right? And the main thing is that over here, we're going to take that object and point it to a URL. It is a normal in-game object. This is the Unity editor, if you've never seen it before. And we're going to point that in-game object over to our URL. So what we're making today is significantly more basic. So once we press play, what you'll see is effectively we have a local sort of basic Angular setup where I log in. And once I've logged in, we have the Unity space behind it. I press the button to create a block, and a cube shows up in the scene. Over here on the left, we also have a list of all of the cubes that are there. And so this is we're going to walk through all of these steps to see how we both send a message to Unity and get that message back. So first of all, we're going to set up Unity to listen to the browser. So as I said before, we're going to take our browser GUI, which is an object here in the scene, and we're going to point it to a local URL, or you could set it to a website, a normal web application URL. And that's what it's going to display over on top of the Unity space. We also have another object in the scene, which I'm going to call the cube spawner. And the cube spawner has one script on it, which is called spawn. As you can imagine, all it does is it creates a cube. It has a function called createCube, very simple. And if we look at the body of this function, this is in C#. All it does is it creates a primitive, gives it a random location, assigns it to be a child of the cube spawner, and then we also message with the browser and tell it that we have actually added a child, sending that data back. We're going to walk through all of these steps in a bit. But here we have the browser messaging service, which is also an object in the scene. The first thing you'll notice is that half of the code is actually grayed out, right? So Unity is really good at doing something that we call compilation-specific code, or environment-specific compilation. So because I have this if not Unity WebGL up here, this top part is going to be used when it compiles and when it builds. But otherwise, we're going to use the bottom portion of our code. So we'll get to that in a second. But effectively, we have the same function being used on both of the sides, which is just send browser message, either with a Unity event or a Unity game object event, which is one that I've created, and that's the one we're going to be looking at. And at the beginning, we actually register a browser function that we are going to listen to. This is in desktop. So we get a reference to the browser itself, and we're going to register a function called sendMessage, which is a global function that we're going to define in the browser. And whenever we call it, we're going to get the arguments. The first will be the name of an object in the scene, and then the last two arguments are going to be a method and an object, and a method, an added reference that we can pass to the method. And as I said, down here we have send browser message, which is just going to call a function in the browser, which effectively dispatches an event and sends some serialized JSON data over to it. The important thing here is GameObject.sendMessage is actually a normal Unity function. This is something that Unity employs regularly that you can always use. And as I said, it takes in a method name, and it takes in an extra option for a value to send as a parameter to the method. And you can always get a reference to a game object and then call GameObject.sendMessage. Unity uses this regularly for its own event system. So this is nothing this is nothing special that I've made. This is just Unity itself. And the other thing we have to do is have the browser send messages directly to Unity, okay? So if we look at the body of what the browser application is, it's a very simple Angular application, where in the background I have a Unity application which will run in WebGL only. And in the front, we have the router, the normal router outlet, which we'll use for all of our pages. Important thing is here, on the Unity component itself, I'm not actually going to do anything on desktop. In the browser, when we build for the browser, Unity will give you an additional file called Unity Loader, which will actually take your game, load it in the background, and then tell you when it's done. So that's what this is for, but we're not using this for now. We have a service as well that I've listed here, and this Unity service is another function that I've made which gets dependency injected into it, and it has a function called sendMessage. And when we are in WebGL, we'll get the game instance, and we'll actually send message, which is the name of the object, the method, and the value. Likewise, in the desktop version, we're going to call a global function called sendMessage, and do the same thing. The important thing is here in TypeScript, I've declared a global function so that we can actually just call it as though it were a global function. And over here in the home page, I have the list on the left with a button that calls create cube. Very simple. If you look at the function, create cube, actually it just calls this very, very simple function called create cube, which will send a message through the Unity service to the cube spawner with the method name createCube. Go back. So again, going back to createCube, this is a very, very simple function. This will message with this object. This is what will get called. We'll create a primitive, and then we'll set it to we'll put it in the scene, and then send a message back to the browser. So let's look at that just again. Pressing the button here, sending a message over to the Unity space, and this is what calls createCube. This will call the Unity's version of createCube, and then we get a new object. So Unity messaging to the browser. This is a little bit more intricate. So back here in our cube spawner, whenever we call createCube, we also call message service send browser message. And this will send a new Unity game object event, something that I've created. We'll go through a little bit. And we'll say that we've added a child, and we'll tell which is the object that's sending the message, which is cube spawner, and the extra data, which is the child that was created. Over here, whenever we call this function, we actually just dispatch an event, as I said, along with the detail of that event, which is the data that we sent. And we convert it to JSON using a library called JSON convert. Pretty simple. So the important thing here is the Unity game object event is something I've created, and it has a reference to something called a Unity game object. Normally, Unity does not allow you to serialize game objects to JSON, not simply anyway. So you have to provide something similar, which will serialize the data itself, the things that we care about. So I've created this Unity game object as a serializable object, and it has two main things. It has the name, and it has a transform. Transform is going to hold our position and rotation information, and that's going to be the position. These are also, the Unity transform is also not serializable, so I had to create this class as well. So this Unity position is X, Y, and Z, and the rotation is X, Y, Z, and W. Every time we create an object, we're going to send this data to our browser messaging service, serialize the data, send it to the messaging service to send it to the browser. Over on the browser side of things, first thing we notice is that we have an observable of our DOM events, specifically the ones for Unity message. And whenever we get one of those, we're going to parse the val.detail as a Unity event. And this Unity event, if we look at it, is exactly the same as the C# version of the Unity event that I created. Right? This makes it significantly easier to parse it. And we already know what it is, right? Either it's a string or a Unity game object. which is the data. The Unity game object, if we look, is a name and transform. Transform is position and rotation, and this is X, Y, and Z and X, Y, and Z, W, respectively. Again, this is exactly the same as we had in the desktop version. So over here on the home component, whenever Unity sends us a message, we're going to first make sure that it's one for add child. And then whenever we do that, we're actually going to add it to our list of children as a Unity game object. In our Unity game object, our list here is specified to listen to the position information of the Unity game object. So we can look at this interaction one more time. Again, we press this, send a message to Unity. Unity sends a message back with the name that was randomly generated and the X, Y, and Z information, along with the rotation, but I'm simply not showing that for now. So, Unity, WebGL, and isomorphism. What do we actually have to do to make this work in both environments? So first things first, when we build for WebGL, we don't need this browser GUI anymore, right? Because we actually have a browser. So first thing we do is we remove that, but we still have to give Unity a way to interact with a browser, right? So we have to create a plugin, which is called a JSLib file. It's just any name.jslib. And we have to put in certain functions there that we want Unity to be able to call in the browser itself. It looks like this. This is very specific syntax for this very specific file. Unity gives you this. You just need merge into library manager.library, which the Unity loader actually creates when you load that file. And we created a function called _send browser message. The body of that function looks exactly the same as in the desktop version. And we're just going to call the exact same thing with this pointer stringify right here. Right? This is actually a very special function that Unity gives us for working in WebGL specifically. And there's a set of them. So if you want to do anything more complicated than that, say printing a float array, taking an array of values and sending that to the browser, you're going to have to use this very specific functionality there. I would prefer to just use JSON. It's the simplest thing on the planet, and everyone uses JSON, so I tend to just stick with JSON. And back in the browser messaging service, the important thing is once we've gotten to the WebGL version of things, the top half is actually grayed out, because Unity is not going to use that when it compiles. It's going to use the bottom portion. And we still have this function, send browser message, with the same signature of a Unity game object event. And this has an extra function here called _send browser message. Both of these functions just call send browser message. And this DLL import internal statement basically says, or annotation says to Unity, that this exists somewhere in some plugin file. I'm just going to go and find it, and I will call that function with this signature. That's all. We already created that file, so we know exactly what that means. Back in the Unity component, as I said originally, in the WebGL environment, we do have to load the Unity loader. It's a file that's provided after Unity builds the game for you, or the application. And we'll start the game and tell our Unity service that this is a reference to the WebGL Unity application itself. Over here in the Unity service, once we have that reference, in WebGL, we are going to call game instance send message, which is actually an actual method on the game instance itself. You can look through the documentation to find this, but the reason I created this method to be exactly the same as this is because this is what Unity itself provides to us in WebGL. So this is the simplest way to use the same method name, same signature, without actually changing any code. So in that sense, we've actually created it to be entirely isomorphic. So that's really all you need to do in order to get WebGL and Unity to work together in order to make the exact same application. So it's pretty simple if you know how to use this. And this means that you can use HTML UIs for anything you want to do with Unity. But there's a lot of things I really wish I knew before I started this. So first of all, there's a lot of environments out there. As I said, Unity can build for basically everything. But one of the hard parts of doing that is our Chromium embedded framework does not, in fact, work on everything, right? So with WebGL and desktop, we get the benefit of being able to use both of these together, and it's seamless. It's perfectly fine. But if we're going to use something like mobile, we can't embed a Chromium browser into a mobile application. That's just too much. But what we are probably going to be using is something like NativeScript or Ionic Framework, and we'll embed the Unity application there. Right? Likewise, with Oculus Go, we can't use Chromium Embedded Framework, and so we're actually just going to use the Unity framework itself. One of the good things about what I just talked about is that it's very easy to strip away that HTML layer and just use the Unity application on its own. But what that also entails is that we're going to need to split apart what we would call in-game UIs and our normal work UIs. So over here, we have something that we would expect to be doing in the browser or on a desktop application, right? We actually want to work with a lot of data. But over in-game, say if you press the pause button, you don't expect to have something like this show up, right? In VR, you don't have that choice either. So you have to make this very conscious thought of figuring out what are going to be these in-game UIs and what are they going to look like and where are they going to be used, because these UIs are going to be shipped with everything, whereas these UIs probably won't, unless you're only building for desktop and WebGL, in which case it's fine, right? But this is a very important thing to note and keep track of, and something that you'll have to make sure you still use the Unity UI layer for what it's necessary for, which is in-game UIs. And then there's the language compatibility level. I think this is probably the biggest problem I ever had, where I would basically say you should start with building for WebGL and then add more features for desktop. Effectively, what this means is whenever we build for something, we have to choose which version of .NET we're using and which version of C#, which also entails which version of C# we're going to use. A lot of the libraries that we pull in when we want to build things, say for JSON parsing, those might be very new, and they use a version of C# that's very new, C#6. But when we build for WebGL, we can only use C#4. We have to use the lowest version of .NET, which only allows us C#4. And so when I did this, the first time, I built it for desktop, and I was like, yeah, this is really great. This is super easy. Now let me switch and build it for WebGL. And in WebGL, everything broke. And it broke entirely because of these libraries that I was pulling in that I had to literally pull out of my whole project. So I had to go then and rewrite all of my code to work with something that was compatible. And I had to do this multiple times because I didn't realize that I went from desktop to mobile, fixed it a little bit. Then I went from mobile to WebGL, fixed it a little bit. But then by then, it was an entirely different project, right? So I would definitely say start with WebGL. It's the most restrictive environment you have, and the fewest things are going to work for it, and add more features as you go along. So this is actually, I had so much of a problem, I definitely wanted to list this. This is an asset in the asset store, which actually works for all versions. This also works for WebGL, as well as mobile, as well as desktop. And I think I actually spent probably a good 2 weeks doing this the first time, switching JSON libraries specifically for this purpose. So eventually I found this. This is very well supported. It's one of the best ones you can have. And so with that, you are pretty good to figure out how to go forward with this. But the real question is, what are you going to do with it? So I have a mission for you guys. Okay? What I want is for you to take these normal applications and turn them into something far more interactive, far more engaging. I want you to be able to take something, oh, is this going to play? I want you to take something like Wikipedia and be able to make it something that people can actually engage with, people can actually see as they're reading that information. And obviously, if you're learning about the body or the skeletal system or any other kind of concept, you should be able to see what it is that you're learning and engage with it in a far better way. Unity is going to give us that ability, but also as web developers, we have the tools to make this far more ingestible. So with that, I'll say be creative, and thank you.
I had to bring notes with me. That was awesome. Thank you so much. We did get some rather pointed questions, which is a sign that you've communicated a lot. One of them was a suggestion, the other speakers, will you be posting this online for those who want to be able to get a better look at the code samples and so on? Yes, thank you so
Awesome.
much. We had two interesting questions that are sort of related. Actually, no, they're not. One of them is, can you give us a very quick overview or your thought on debugging?
Debugging. Oh.
Okay, next question.
The good thing about using this actually is we've separated out the two things as, either you're doing HTML and doing a normal framework or you're using Unity. Unity has really good debugging tools for itself with Visual Studio Code. And you can do the normal debugging where it will stop at a certain line and show you what all the variables are and so on and so forth. And likewise, because we're using an HTML application, we can debug the HTML application exactly the same way that we would normally do that with our own. I use IntelliJ. You could use Atom. You could use all kinds of things. But they're entirely separate. And the framework that I showed you, embedded web browser, actually allows you to listen to the in-game HTML application in your own IntelliJ or other application and also do the debugging breakpoints. So it works perfectly well if you separate them out.
And speaking of separated, the other question, which is actually not like this, but so important these days, and we're going to be hearing from some people with voice interfaces and so on in a related subject, what is the accessibility story with Unity?
So Unity is not really as accessible as a browser, right? But again, it's made generally for video games. As this, over time, as it develops, more and more people are moving into the Unity space, and I think it will, over time, become more and more accessible. But generally, it's made for video games, so it's not as accessible as the browser is by
Well,
default.
once upon a time, computers were just made for business,
Exactly.
and people changed that. So there's an
Exactly.
opportunity for people who are excited to get involved, right?
And so as more and more people start to develop this in Unity, obviously it's getting expanded out into all of these other areas, right? And so that'll become more and more important.
Thank you so much.
Yeah, thank you.
What a great talk.